It's the Basic Architect here. So, we're back on our Passive House 11 series. Yeah. For those of you not familiar with it, this is a certified passive house. It's in climate zone 5 down on the Cape Cod. And it was designed in '09. It was constructed in 2010 and certified in 2011. So yeah, that house I designed 14 years ago. But it's a lot of things there are details that I'm still using today. So I know we're maybe about a quarter of the way through this series. We're going to go through the drawings and talk about pretty much every aspect of this project, because it was a huge learning experience for me, given that not only was it my first passive house that I ever did that was certified, but when this thing got certified, it was probably one of 4 or 5 in the country. So the American residential building industry was basically learning on the heels of the construction of this house. So today, I know we talked about this detail in the past and how we developed it. This is the that floor detail. Let's go back here. This is the floor detail that's happening down here. If you want a little bit more, the 2 previous videos definitely get into how that detail developed and exactly what it is. But today, what we're going to do is we're going to take this and we're going to analyze the detail in reference to the 4 control layers. Right? And we know them as water, and I'm going to put these in the colors that we're going to use these in: air, vapor, and of course thermal or insulation. Right? So those are our 4 control layers. So no matter what house I'm designing, whatever detail, whatever part of the house, those 4 control layers play a role in it. Now, we're going to get into the detail, but I'm going to give you a little bit of a quiz and see if you can guess right. There's a part of the house where all 4 of the control layers, all 4 of them, are being conducted by one material. So at the end of the video, I'll reveal the answer to that question, but I'll let you ponder that as we go. So let's talk about water first. Right? Obviously, water kills. #1 killer of buildings, right? If you Google the most litigated reason in residential construction, it is a water problem, water leak, something, flooding, something due to water. Water kills, and it's the #1 killer of building. If you want to build a durable structure, solve for water. So, how did we solve for water here? Obviously, we put a cladding on, right? You can see there's our wood clapboard there. Notice we have a drip cap on top of our water table. Notice our water table, and these are small little details, right? We have our sheathing hangs down below that joint, and then our water table hangs down. The reason is, you know, as water accumulates and comes down here, it's going to go there, and the idea is that we give it the opportunity to drip off the wall there. If for some reason it held here and dripped, or the wind blew it on and it was here, then it would drip here and not turn that corner. If it did turn the corner, it would find that face and it would drip there. So we're providing a lot of, I call them drips. I know other people will reference them as the same, but that is the initial water management, right? So that's our primary. And with a lot of our control layers, we have just that. We have a primary and then we have a secondary. So we have our siding. Well, what if wind-driven rain somehow makes its way to the back side of our cladding? Now, this is a pretty strong contention because, believe it or not, there are people out there, and they'll probably even write in the comments, that'll say water is not supposed to get back there. We put sealant at every joint, at all of the ends. Water never gets behind the cladding. Yeah, just start renovating houses that are, I don't know, give them maybe 5-8 years, and then pull off the siding and look behind it and see if there's any evidence of water staining or that. I think you're going to be surprised. Water gets in there, folks, okay? We can't stop it. Water gets in there. And here's the important thing. This is probably one of the most important learning statements in terms of water management, and especially sealant. The minute I put sealant here and I think I'm sealing it out, the question is not what am I sealing out, right? That is not the question. No, you are at a loss if that's what you believe. The real question there is, what are you sealing in? Right? So you put sealant at every one of those lap siding joints or at the ends, and water gets in, guess what? It can't dry out, right? And when it comes to moisture and vapor, and you'll see when we talk about it, it's on a scale of I need to be able to dry more than I wet. So the minute I put sealant on the building, I think, or some people think in their mind, hey, I'm sealing up the building, I'm keeping all the water out, moisture out. When what you're really doing is you're sealing stuff in. Now, here's another way to look at it. If I put a bead of sealant there and it successfully keeps the water out, okay, it's done its job. No harm, no foul. If water gets in and can't get out, then I have a major problem. I've never done a building investigation on a building that kept the water out. We call those successful buildings. I've done literally hundreds of investigations and looks at buildings that water has gotten in and can't get out. Those are major problems when it comes to water. So, how do we solve for this? Well, you can see here, 1x3 wood furring, 16 inches on center, vertical. We instill a space here. And that space suggests now, if we get wind-driven rain, water gets in, just like on the outside, it can now drip down that furring strip and basically drip out here through the mesh. The mesh there is to keep the migration of bugs, which I'm still on the fence about that because they just do not like that space. I know it's a hard one to believe. You're going to tell me all kinds of critters are going to get up there, but they don't. They don't like it. But anyways, we have our venting strip. I mean, Core Vent makes it. Cobra Vent you can cut. There's a whole bunch of, you can put bug screen and staple it over the furring strips, whatever you want. But the ability to get that water out, and that's a 3/4 inch space. Right, so now we have our primary water management, but here we have our secondary. And that is that 3/4 inch space. So I have two modes of mitigation to deal with the water. I deal with most of the water on the outside, but then on the inside, should it get in, I provide a path. And then, of course, you know, when it comes to water management, there's three types of words, right? Protection, mitigation, and prevention, right? So if I look at this and I want to apply the words, the outside cladding system is my protection. The secondary drainage space is my mitigation, right? If water gets in, how do I deal with it? And then, of course, the face of, in this case here, we used zip sheathing and all the joints were taped. That is our prevention. Now, some of you are going to sit there and say, well, what about the holes and the nails and this and that? Well, the beauty of that 3/4 inch airspace is that it equalizes the pressure so that any water that gets into there is basically forced to fall. And with a house that has an air tightness of less than 0.6, there's really no force driving that water through the wall because there's no leakage paths, right? So I think we've pretty much shown how we're dealing with water. Let's move on to air. So air, we have our slab. Our slab gets sealed to our 2x-member here. Our 2x-member is also sealed there and there with sill sealer. We had a bead of sealant there. Basically, it's a, you know, knee bone's connected to the thigh bone kind of thing. And then that's to the mud sill here. But through all of these beads of sealant, we now have our zip sheathing here. And that is our primary, and actually that is our only air barrier on this house. And then that connects via a bunch of, well, that's not true. That connects via, through a series of sealants to our slab, goes across the building, and basically goes up. And when we get up to the roof, we'll pull up the eave detail and we'll run through this exercise again with the control layers there, so you get an understanding of how we go across the roof there. Our secondary air barrier in this case is the fact that we sprayed 2 inches of closed cell spray foam. Now, some of you might sit there and say, well, Steve, you know, you can't really trust spray foam as an air barrier. Well, on this particular house, a couple things. One, we actually tested it just as a zip. You'll see, I got a picture coming up. And then we did the closed cell spray foam. And I think we went from like 32 CFM of air leakage down to 24 CFM of air leakage. Look at the numbers. I did the video with all of the numbers, all the very specific numbers in there. I'm trying to recall them. But I do remember adding the closed cell spray foam meant that we took out another 30% in air leakage. So it does tighten up the building, folks. It does. And for those of you who say, well, okay, maybe it does on the first week or first month, but we've been back to this house and did subsequent air tightness tests, and the building is not losing its air tightness. So, you know, I don't put a whole lot of value in the people that don't believe. If it's a job done right, done well, then I don't think we have to worry about it. But that's our air barrier. Let's talk a little bit about vapor. So, if you followed along on the last detail, you know that this is basically a double wall assembly. We have 2x6, 2x4 here, 2x6, and then a 7-inch space. That basically comes down and rotates and goes across. And here we have, I think we calculated that at 16 inches and then 4 inches here of XPS. And so this is, well, we'll get into the R value when we talk about the thermal controller. But this is, semi-permeable. And the closed cell foam here is impermeable. Right? So the idea is that first, we control the amount of moisture inside the house. So we have a fully functioning ERV in here on a duty cycle that maintains the relative humidity in the house, right? So that coupled with an air tightness of 0.60 ACH50 means that we're really not pushing anything through the wall via air leakage. Now it's very important with the via air leakage, because moisture that moves via air leakage is an order of magnitude over moisture that moves via diffusion, right? So as moisture diffuses through here, it is looking for a cold surface. Well, it's not looking for it, but when it finds a cold surface, it's going to condense. And so the 2 inches of closed cell that we put here, what that does is that elevates the first condensing surface. Right? And by elevating that first condensing surface means elevating it in temperature, so that we're a lot less likely and almost at no risk of getting a temperature where vapor diffusion is going to find a cold enough surface to condense. And if it stays as vapor, who cares? I'm breathing in air that has moisture in it, right? It's vapors all around us. It's no mystery. It's when it condenses and becomes liquid water that's when we have a problem. Now, one of the other nice things about having the 3/4 inch airspace here is, the minute we put that closed cell in there, people are going to say, well, you restrict the drying in the wall system, right? Well, we do. We restrict it at this point here. But now our wall has the ability to dry from here to the inside. And on the other side, it can dry to the outside as well as that 3/4 inch airspace. While we talked about using it as drainage for water, it is also a ventilation path to whisk away and dry out the moisture content of our exterior sheathing or the backside of our wood siding, whatever the case may be. It provides not only what we would call down and out, right? That's our term that we use for water, down and out, but it also provides up, in, away, right? It provides the ability to dry up through that 3/4 inch airspace there. So dry to the inside, dry to the outside. If we're looking down here, again, the whole reason for the 4 inches of XPS is we elevate that moisture or that first condensing surface. And we put it at risk. We basically took this wall, turned the corner, and put it there, right? This is, probably somewhere around R14, and we talked about this being R20. So that, this has the freedom to dry that way, but that really doesn't have as much risk of getting wet as, say, the ceilings or the walls do, unless, of course, a plumbing leak, which we were almost crazily specific about. Pipes went all the way from upstairs through this space, so there is no joints. The joints are down here or up here. Those were always solid pipes going through the system, so we never wanted to put a joint in any of the plumbing pipes there, because if the joint failed, then we would have a major problem. So we're going to make sure all water, up or down, bypassed. And actually the up water, it was coming in from above, so only drain water basically goes through that system, and it goes through a continuous pipe. So let's move on. Our last one, thermal. You know, the beauty of it is if I solve for water, I get a durable building. If I solve for air, I get a pretty damn energy efficient building. And if I solve for air in thermal, I pretty much solve for vapor. So I don't have as big a problem there. So thermal, I always tell people, it's one of those things that it's put in as pretty much as much in insulation as the budget will allow for. In this case, we had to deliver a passive house, so we had to meet a certain level of insulation that would meet a certain energy requirement per square meter of surface area on this house. So we had that, but we'll run through. We talked a little bit about it. We have our 2 inches of closed cell foam here. That is, let's just say R14. It's R13, 14. And then we have 14 inches of cellulose across there. So the 14 inches is 40, 56. Let's just say that's like 54. So 54 and 14, that's an R68 wall. And then for the floor system, we said we were at 16 inches. Again, 16, that's 40, 64. That's probably somewhere around R60 there. And then, of course, our 4 inches, we talked about it being R20. So that gives us a grand total of R80 on that floor system. So R80 up to R68, R70. As we turn the corner, you can see that's how we met our enhanced insulation package to certify as a passive house. So I threw this picture up. We did do, you know, one of the things that was slightly different about working on this house that others was the window manufacturer was absolutely horrible about delivering windows to us in a timely fashion. Kept saying, okay, they're going to be there in a week or two, and then in 5 days it was, oh, sorry guys, they're not going to be there in a week. It's going to be another 3 weeks, and they kept putting it off. So remember, this year, 2010, Zip is in its infancy, right? Meaning it has just come on the market. It's the new kid on the block, right? At that time, we're still using plywood and taping house wrap and all of this. And now Zip comes along and says, hey, we can give you an integrated weather-resistant barrier already attached to a structural sheathing. And then you just have to tape the joints. So we bought into it, and we're working on the project. Windows are late. And so I look at the builder and I say, hey, I know it might be a little bit of work, but why don't we have the framers, we'll just do a full zip coverage over all of the windows. We'll leave one door open. And you can see it there. We'll leave one door open. And we basically blanket it. Remember, Zip is our primary air barrier. So our slab was already in place. We had our drywaller come and put the ceiling in place now that the roof was on. And now we can do a blower door test. And not only is it a blower door test, but because it's the gypsum board and the foundation are already in, what we're really testing is the validity of the Zip as an air barrier. And yeah, it came in at like 32 CFM of total air leakage there. I mean, the number was crazy. I mean, it was probably like 0.16 or something like that. In that numbers video that I shot early on, it's in there. We did the 4 blower door test, but it's crazy low. The reality is Zip is an air barrier, okay? And not only is it one, it is a very, very good one. Fully functioning, works extremely well as an air barrier there. And we did 4 tests where we did just the zip. Then we sprayed the 2 inches of closed cell spray foam on the inside. We did test number 2. And we took out 30% of the air leakage. So we got that number way down. Then we got the windows and we cut in the windows. And we tested it again. And when we tested with the windows, we did test 3 and 4. We did test 3 as a negative, and then we did test 4 as a positive. The reason you do a negative test and a positive test, well, if they're casement windows and I do a negative test, I'm sucking the sashes against the weather stripping. So I'm aiding the window in its airtightness. But what happens when I turn the fan around and I try and push the sash away from the weather stripping? Now, if it's a crappy window, then I get crappy results and I get to identify that. But this gave me the ability to isolate different things and understand what is it worth when we cut holes in the window and put the window in versus what is the value when it's just zip. Does adding closed cell spray foam change that number? All these questions were answered in those 4 formal tests here. Those 4 formal tests. And you looky here. What we also did was a fog. You can see the fog coming out there. We put a fogger in there, turned the fan around, and highly pressurized the house, and then went around the outside looking for leaks. I will tell you this. The place failed in about 4 places. And when I say failed, meaning I saw smoke on the outside. And it was pretty interesting because all 4 places or 5 places where I saw it was highly isolated. They were all right in here. And the reason is, that is where we relied solely on closed cell spray foam there. So they were very, when I say small leaks, it wasn't like it was pouring out. It was probably barely enough to see. I tried to take some photos. There was such little smoke that in the photo you can't even see the smoke. The photo made it basically go away. But it did leak in 5 little spots there where we used the closed cell spray foam. So the takeaway from that was closed cell spray foam does perform well as an air barrier, but it's not perfect. And a lot of it has to do with who's spraying the foam, the time of year, temperature, all of these things play a role. One of the problems with spray foam is that there's so many variables between success and failure that you really have to pay close attention and hire a very good insulator that knows what they're doing, but also has really good installers there. So let's just jump back right quick because we had the one question here. I'm going to switch to blue of what is the one material where it's all 4 control layers? Have you guessed it? Yeah. Glass. All right, our glass window. It takes care of water. It's an air barrier. It is a vapor barrier because it's impermeable, and if we do an IGU, that IGU is part of our thermal control layer. So the glass of the window. All right. Well, there you have it, folks. I'm Steve, Basic Architect, using my new Vibe board. Hopefully you like this. If you wouldn't mind, I would greatly appreciate some feedback. Are you loving the Vibe board, the ability to switch between different, they call them canvases, they're simply pages, right? You get to go between different pages. I can upload different details, photos. I can play video. We can jump to the internet. let me know what you think about the format here. Let me know what you think about going back in time and talking about a project that I designed back in 2009. I mean, there's still a lot of things that are extremely relevant here. If you're looking for more, I'm a contributor on The Build Show. I'm a co-host on the Unbuild It podcast with Jake Bruton and Peter Yost. We have a lot of fun there. You can find us on YouTube under the Unbuild It Show there. And you can actually watch the antics of the podcast. And the podcast has recently come under the umbrella of the Build Show. So you can find us on thebuildshownetwork.com. If you're still looking for more, Steve Basic Architect on Instagram, Steve Basic on LinkedIn, Steve Basic Architect on Facebook, on TikTok, and of course, you found me here. So hit that smash. I always say hit, but it should be smash that subscribe button. Tell all your friends, and until next time, long live our buildings.